All right, today my plan is to do Lab 7. Okay, but I'm checking with you. That's what we want to do, right? But first, the quiz 2. I didn't grade those yet. I will grade those tomorrow. So I'll hand those back to you on Monday. So we're going to wait on the quiz 2 results. We'll look at that on Monday. So today, what we can do is go into Lab 7. But please catch me here if I'm in the wrong spot. Is that where we want to be, looking at Lab 7? Or is there something else that we should do? Huh? Lab 8? Oh, so we did Lab 7 already? Huh? We did the first 2. Do you want to do the third problem in Lab 7? Or let's do the third problem in Lab 7. What is that problem? Okay. So I'm just going to start by creating the test code. I'll create the test code first. Actually, we don't need that. I'm going to leave that out. Here's the first version of the test code. We just print all tests pass. There we go. Let's see if this test code runs. And we'll run it. It compiles. It runs. All tests pass. All tests that we have so far are good. All right. This is called a test first strategy. This is very popular right now. Interview for a job and say, yeah, I do testing first. I write my test code first, and then well, you're going to sound very disciplined to that employer, and they're going to say, that's great. That's the way we do things here as well. Although maybe, or they'll say, that's great. That's the way we should do things here as well. So you'll get one of those 2 different replies. All right, here's the problem. Suppose that a vector v contains a sequence of integers ordered from lowest to highest. Okay. For example, v might contain the values 3, 6, 7, and 12. Well, there's a suggested test right there. Let's just drop that in there. So we have v equaling this. Okay. So this is a sequence of numbers that are ordered from lowest to highest. So write a function insert. Well, that's the name of the function. Write a function named insert. Maybe I'll just modify that. Write a function called insert. Write a function called insert that takes this vector v as a first argument and an integer k as the second argument. Now, let's get started on it. Let's see, what does that mean? Let's go ahead and code it up. So v, function, there's a function called insert. And we don't know the return type yet. So there's a function insert that takes as the first argument a vector v. Let's say a vector of, was it an int, right? and an integer k. Is that what it was? Write a function called insert that takes this vector v as the first argument, so it's a vector of integer, and an integer k as the second argument. The function inserts k into the vector so that it preserves the order of elements. For example, if v was 3, 6, 7, and 12, and k was 8, after calling the function v, v would be, I wanted to say then. Then after calling the function v, comma, v would be, there we go, that's how to read it, sorry. All right, so we're going to insert A, and then we should get this result. Okay. Here's the test. That's the v, and then we insert k equals 8. We'll say we'll insert 8. It'll look something like this. We'll have the vector v. We're inserting the value 8. So we call the function, which is insert, like that. And the result should be those numbers right there. Okay. So we have v like that. Then we call insert, passing in v and 8, and then the result is that v equals, I'll just like that. V equals that. So 8 is put after the 7 and before the 12. So it's a kind of like an insert operation that preserves the order of the elements. So notice that we don't need a return value here, so we can declare that as returning a void. So that's returning a void. So this, and remember, I recommend doing things in as small a sequence of steps as possible. And I would build this right now. Is this declaration of the function, without even calling it down here, is this going to compile? Well, it doesn't. It will not compile. Why? Yeah, let's see why. So it's missing the include directive. So let's see what happens when we miss the include directive. Variable or field insert declared void. Vector was not declared in the scope. This is the one I'm concerned with. Vector was not declared in the scope. Expected primary expression before int. So it doesn't take this. So here's the solution to that. So we add the include statement there. That looks good. All tests passed. Great. Test driven. That's what they call it. They call it test driven development. And all right. So now let's go ahead and try to get this get the test code written here. So we declare a vector of int called v. And let's add to that vector 3, 6, 7, and 12. And we'll do that by calling pushback. So we push back 3. 6, 7. Can we do what?
Can we declare the vector initially without having to use a pushback for every number?
I don't think you can. Does anyone know how to do that? I don't think you can. In other languages you can. In JavaScript, I'm learning JavaScript right now. And it's very convenient because when you declare your sequence of values, you can specify that initialization right there in the declaration. But with C++, you can't do that. This is inconvenient. If it was an array, we could do it like the way that you suggest. So if we had an array of int called v, then we could do it like this. We can do the initialization right in the declaration statement, but not for vectors, right? We'll just test to see if that compiles. So this is not quite right. It's a brace. Okay, it's called a brace. So yeah, once again, it's more convenient in other languages. So we push these things, and then we call the insert function. But you know what? I recommend doing things in steps. Let's just see whether this builds, okay? So there's an error. It's saying there's something wrong with line 23. Error. Expected unqualified ID before. Now once again, I just haven't configured my terminal program correctly. That A hat should really be a quote. So it's complaining about this this square bracket. Expected unqualified ID before the square bracket. So actually I don't have the expression quite done correctly. And I believe that it's in fact this. Just put that in the wrong spot. Now that's good. Okay. So we'll take that out. That's just to show you that you can do it. You can do the initialization more compactly using a vector. I mean, using an array. But the difference between an array and a vector in our case here is the vector is the size is changeable. We can add members, we can remove members, or add items or remove items. But in an array, you can't change its size. The initialization of that array that we just saw there. Oh, that's not working. The initialization of that array, I think we passed in these 4 objects. That means the array would be of size 4. We wouldn't be able to change that size, but we can change a vector, the size of a vector. All right, let's call the function now. It's called insert. Ooh. And we pass in the v. And we pass in the value 8. And now we want the test code. How does the test code look? Well, let's use assertion. So it's assert a v of 0 should equal 3. Now to use assertion, we need an include directive. We need to include CSUSB. And so calling insert on this vector, see here's the initial state of the vector looks like this. When we call insert, 3 is still in the first slot. So the test should pass because we're only testing the first position. So let's go ahead and run that test and see if we got it right for the first position. Good, that's okay. You see how I'm doing this in very small increments of development? I highly recommend that you work like this. And let's continue with the testing. And I'm going to clean up that comment in a minute. 3, 4, 5. So there should be 5 values here. So we replace 1, 2, 3, and 4. The first slot should be a 3. The second slot should be a 6. The third slot should be a 7. The fourth slot should be an 8. The fifth slot should be a 12. So that's it. So these are the spots beforehand. We insert the 8. This should be the result. And I'm going to take this out because now the test is sort of clear at this point. I don't need to leave that comment in there. It makes it harder to read. Take that out. It's a temporary comment. Now this should fail, right? Because it's this line here. This line should make it fail. There it is. Assertion V of 3 equals 8 failed. Okay, that's exactly what we want, right? All right, let's go ahead and implement this. So let me use I'm just going to use this little area here. So let's think about what we have here. We've got a vector, and we've got 4 positions in it, say in our example. And these have indices. This is index 1, this is index 2, this is index 3, 2, and 3, like that. And these spots have values in them. Let's go ahead and look at that. So that's a 3, a 6, 7, and a 12. That's what our vector looks like right now. And it's a little hard to see that. How about that's better? So here's the algorithm. There's different ways of doing it, but the way that I'm going to do it is as follows. We'll take this vector here, and we'll append a new slot onto the back. And we'll put something in it. We'll put the new value in there. We'll put the 8 in there. So we're going to append the 8 onto the back of the vector, because there's no command to insert something inside the middle. So that's what we're implementing. We're implementing that insert function. So we need to, the result is going to have 5 items in it, so we have to increase the size of the vector. And when we do that, we have to give it some value. We have to tell it to, put some value in the new slot. We could put a 0 in there, we could put a -1 in there, we could put a 12 in there. That's what a lot of students were doing. That's the last value on the vector. But I think the way I'm going to do it, I'm going to put the 8 in there. And then I'm going to do this. I'm going to start at the end of the vector, and then I'm going to swap these 2 positions if they're out of order. So this is the first step. the first step here is we're going to append. We're going to append to 8. And then we're going to then what we're going to do is we're going to compare. Well, we're going to have this variable, this pointer. Let's call it I, and we're going to set I to the which position do I want to do it? Let's set I to the last position, say. So it's 0. This is position 4. So I'm going to create this index, an integer that just keeps track of what I'm going to consider to be my current slot in the vector. So slot 4. You've got slot 0, slot 1, slot 2, slot 3, slot 4. So I is slot 4. And so I'm going to append the 8 here. Then I'm going to initialize I to the size of the vector, -1. And then I'm going to compare V of 4 with V of 3. And this 4 comes from the I, right? So I'm going to, or essentially I'm going to compare V of I with V of I -1. And in this particular case, because I is 4, we're going to compare V of 4 with V of 3. So V of 4 is 8 and V of 3 is 12. So the vector is going to be an increasing sequence. So V of I is now smaller than V of I -1. So we're going to swap them. So let's see what happens. So we're going to, in fact, swap these. So that means that this becomes 8, and the last slot becomes 12. So we're swapping. We're swapping those. And then when we're done swapping those, we're going to decrement I and make I 3. So let's see, this is slot 0, 1, 2, and 3. So now, see, I is pointing to the slot that has the new value, the k that we passed into the function. So we're going to let I be the index of where the new value currently is. And what we're going to do is we're going to start at the end of the vector and kind of swap it with its preceding element until it's bigger than its preceding element. And once it's bigger than its preceding element, we don't need to swap anymore. We're done. And so at this point we set I to 3, and then we're going to do the next step, which is to compare V of I with V of I -1. And either swap or return. Because if we don't swap, it means we're done. The value that we just inserted, if we don't swap, it's because the value we inserted is now bigger than its preceding element. So in fact, that's what happens here. 8 is bigger than 7, so we don't need to do any swapping. We just return from the function. So how do we do that in code? Does everyone understand the procedure? I mean, it's not hard, right? You've got a list of things. You put a new one on the end, and then you just swap until the thing that you just added is less than the one after it, but bigger than the one before it. This makes sense. Now the hard part is is how to express it using variables and functions and vectors. So let's see how to do that. Well, obviously we're going to have a loop, right? So we're going to have we've got an I here, and we got to set that to something. Huh? Something like that, yeah, that's right. A dot size minus 1, V dot size minus 1. Well, it depends on where you do it, okay? There's just a suggestion there. There you go, like that. You got an intuitive feeling, you write it down. And then we're going to check it later on. We're going to check the log. Maybe we're probably off by 1, or maybe we're not. So you got that intuition there. It's going to be set to something V dot size minus 1 or plus 1 or nothing. Well, we'll got that in there. Now, remember up here, the first thing we did was we appended the value coming in. Let's do that. So appending is pushback. So we're going to push back the 8. So this, you know, what we're looking at up here is a specific example, but when we implement the function, it's generic. We don't know. V could be empty. V could have a million things in it. But what we're going to assume, and we're going to call that a precondition, and that's what they call it. This is a precondition. A precondition for this function is what? It can be empty. You know, the precondition is not that it has something in it. We can always insert an element in a vector that's empty. It makes sense, but we can't correctly insert a value if the vector is not already sorted. Okay, that's the precondition. So the code isn't going to make any sense if V is not sorted. Well, we're not going to check. We could actually check that. We could create a function that checks to make sure that the vector is sorted. But it's kind of an expensive operation. Actually, we could build a check. Yeah, we could do that. We could check that. Well, let's not check that. Let's just assume that V is in fact sorted. And so we push back the 8, and now remember I is set to the location of 8. So it is you know, V dot size is 1 more than the last index, because counting starts at 0. See, like here, after we append the 8 here, what we want I to be what? We want it, well, see, this is position 0. The size is 5. But if we start counting at 0, we get 0, 1, 2, 3, 4. Oh, okay, so the size is 5, but the last index is 4. Oh, we got a one-off situation. Our index that points to k that we just inserted must be V dot size minus 1. So now that we applied that reasoning, we had that gut feeling, that hunch, that, you know, that was it. Now we just sort of verified it with a particular example and with general reasoning as well. So we're confident at that point that that I is the index of that 8 that we just added. All right, now we have the loop. So I'm going to make that a while loop, because and there's my why I'm doing this on a hunch. What's the hunch? Well, a for loop is good if you know exactly how many iterations you want to do. And we don't know exactly how many iterations we're going to do here. So I'm going to just start with a while loop. That's my first guess. Well, you know, of course, you can whatever you can do with a while loop, you can always do with a for loop. The question is, which one looks prettier? Which one is easier to stare at and understand? And I'm going to guess that the while loop is the best choice at this point. So what is the condition? We're going to do this loop while v of I. That's the new value. The new value 8 or 20 or whatever we put in there. That's the new value. Well, this value is less than the value that precedes it. why is that? Why is that what I'm doing here? Because right, if it was the other way around, if v of I were bigger than the value that precedes it, then we're done. Then then we're finished. There's nothing left to do. So let's suppose we got this situation where the new value is bigger. I'm sorry, the new value is less than the value that precedes it. So we're going to swap. That's what we figured out. That's how we thought about it, right? So how do we swap? Well, we already have the new value. The new value is stored in v of I, but it's also stored in k. So we can clobber what's in v of I without losing the value, because we can always get it out of k. So we don't need a temporary variable. So that's what I'm getting at. Not that you were thinking about it. So we can take what's in v of I and assign what's in v of I minus 1. And then take v of I minus 1, the slot at v of I minus 1, and write into it k. And then, what's the last thing we got to do here? We got to remember, what does I is the index of where the k is. We just put it in a new spot. Yeah. And some people would do it like this. That would be the way I normally do it. Is that easier to read or harder to read? Is this easier to read like this? It doesn't. The compiler doesn't care. So I'm just thinking about the human the human element here. Which one is easier to look at? I think it should be consistent. My rule is, if in doubt, more space is better. I like to see space, but that doesn't mean that's the right way to do it. All right, so it's kind of there, right? But there's something missing. This will work with the code, with the example that we have. Let's try it. No, it doesn't work. What happened? We call it here. Oh. Well, this is going to be a little hard to understand. What happened? This one's a tough one. Why did the test fail? V of 3, this is where this kind of work gets tough. Why did V of 3 not equal 8? Is there anybody that can get this? This is where it gets hard. This is the hardest thing we're going to do today. Yeah? No. This is like a trick question here. Yeah, back there.
Shouldn't the v pushback 8 be taking the k value?
Oh yeah. Of course, we're going to get the same result, but that is correct. Very good. Thank you for that. That is not it, because in fact we're only calling it with 8. Okay. So let's verify that we get the same problem. But thank you for noticing that. Same problem. This is a $64,000 question. What is going on? What is going on here? What is the book? This is really important to understand this. When you call a function, what happens? This v here, right? this is what happens here.
Can you pass the vector in my reference?
Exactly. Good. You got it. Well, let's test it, okay? I'm never sure until. We got to pass in a reference to V, because what's happening is we're passing in V and the compiler generates code that makes a copy of V. We operate on the copy. We don't operate on the original V. That's it. That's what let's verify that before we're too confident. It works. Do you see that? The ampersand means that variable that's being passed in, when I operate on that variable, when I operate on that object, I'm going to operate on the object that was created on the outside of the function. And you're just giving me a name of the object. You're saying, it's V, do your work on V. But if we leave this out, we're telling the compiler, hey, make a copy of V. Make a copy of the vector that's passed in. You know, I got to make this a little bit easier to think about here. Let me, let's call it A, because it's a little confusing. Well, I was using V because it's the first letter of the word vector. But, you know, the V here and the V here were different. And so I'm just trying to make a point. I'm using A now instead of V, just so that you can see that. That the V that gets passed in here to this function, the compiler says, okay, I'm going to make a copy. We're not going to touch your V. I'm going to make a copy. And so we're not going to actually, we can analyze the stuff that you passed into us, but we can't modify it because we're working with a copy of it. So we don't want that. We don't want to work on a copy. We want to modify the vector that's being passed in and have the caller see the result. Let's test it. We just, oh, bug. V was not declared in this scope. Oh, there it is. Okay. We need more test cases. We need a lot more test cases. Let's suppose let's create another vector. Let's call it vector 2. Or, you know what? We don't have to create another vector. We can do this. We'll just do this. Just do v dot, is it clear? Does that exist? Is clear a vector function? Let's just see if it builds, right? Does anyone know if it doesn't? Oh, it builds. It builds. And so V is empty. So when we insert 88, you know, there's one slot. It's 88. Let's test our reasoning here. So, you know, you're learning this. You're learning about things. So, you know, we're making an assumption that clear removes all the elements. Well, maybe it does something else. Let's just test that the size of V is in fact 0 after we call clear. So do that with an assertion. Programming with assertions is very important. And there's going to be additional test cases that you should include in here. You should try many different test cases. And make sure that you get it right. Actually, it's not really too many test cases you need, actually. This is pretty good. This is not a copy of A, no. A and V, because I'm using the word reference, okay? A and V mean the same thing. Huh? We're not using what? No, what is vector A? Well, you know, you've got you've got a person, Mr. Smith. You call him Mr. Smith. I call him Sam. I punch Sam in the face, and you say, "Well, you didn't punch." I punched Mr. Smith in the face. What? A and V, they are the same thing. They are just two different names for the same person. The question is the scope. You didn't know his name was Sam, but I know that. But that's in my private scope. So we can talk about, Mr. Smith, and it makes sense to you. But if I say I punched Sam in the face, and you're going to say, "Well, I don't care about that." And when you say, "Oh no, if you knew it was your beloved Mr. Smith, then there'll be a different matter." So that's the thing. It has to do with scope. That where is the name recognized? These names V and A are recognized in different scopes, but they name the same thing, and that's a different concept. I'm playing too many video games these days. That's why I thought of punching him in the face. It has those effects on you. Okay. I think that's it. Let's take a look at Lab 8. And try to do this a little more quickly. Okay, I made a copy of our program, and before I delete code, let's see what it is. Oh, it's a completely different type of problem. It looks like we're going to be implementing this function, so I'm just going to, before I start doing the reading, start to jot down what it is I think we're going to end up needing to look at. And so we'll have that function. I'm going to paste that in here. Oops, something is wrong. So we're going to need to test this. We don't have a vector, so we can take that out. And that's a good habit to get into. Don't include more than you need. And let's go ahead and test the test code. Whoop. These were not declared. So these, I use uppercase letters for all of these. So it's, trying to remember, is it const? It's supposed to be like a constant. Is it const int rows equal I think we got them in here somewhere. It's up there. Rows and cols are some constants. Alright, so we got to define them. Let's say rows are 3 and columns are 2. So let's start small. Those are predefined constants. And then alright, let's see if it builds now. Okay. Suppose that the array of int A has rows, and cols, columns, where rows and columns are some constants. And I just showed you how to declare and set a constant. Implement a function called add3 that uses a loop nested inside another loop to add the value 3 to each element of the array. So we want a nested loop. We want one loop nested within another. And what we want it to do is add the value 3 to each element in the array. The declaration of the function is shown above. Write test code that thoroughly tests the function. The test code should use assertions. And so this function here, we're going to call, we need to declare this. Let's, we have an array A, and to avoid confusion, I better call it B. And that's an array, and it will have 3 rows and 2 columns. So it will look like this, I think. It will have values in there that'll look like this. There is, it's like the first, so there's always this question, how is it, we did in, oh I see, this has to be like this. This is rows and columns. I don't work enough with this syntax to remember how to do this quickly, but I can remember how to do it slowly. How do I initialize that? Does anyone know? I know I can do the following. I just don't know what the initialization looks like. Can I do this? Put in the first slot, I'm going to put say a 0 there. Does that make sense? Is that syntax correct? Let's build it. Incompatible types of assignment of int to int of 2. So this is oh, maybe it looks like this. That's it. Is that it? From the book? There we go. Okay, we got it. At least that works. All right. There's going to be some convenient way to initialize this as well, and we can try that in a moment. But let's do it like this. So let's do, the row 0 and in column column 1, we'll set this to we'll set that to a 1. And then in row 1, column 0, we'll make that we'll set it to a 10, and row 1, column 1, we'll set that to an 11. And we have actually this. this here, we have 3 rows, right? So let's see. Let's try this. Now we have row 2. We'll set that to the first column of row 2. We'll make it a 20, and the second column of row 2, or the third row, we'll make that 21. That's getting confusing. So this declaration here, that allocates a block of integers that is 3 by 2. There should be 3 by 2 integers there. So it should be 6 integers. That means we need 6 assignments if that's going to be valid. In fact, we have that. Those are the 6 assignments. And now what we'll do here is let's call add 3. Oops. Let's call add 3, and we're going to pass in the b. And when we're done, we should get the following type of assertions passed. B of 0, 0 should equal 3. B of 0, 1 should equal 4. Is that right? We're adding 3 to every element. And then B of 1, 0 and 1, 1 will equal, let's see, that would be 10 plus 3 and 11 plus 3, so 13 and 14. Oh, I just put a 1 in there. And the B of 2, 0 and 2, 1, I'm going to guess it's 23 and 24. Okay, once again, I'm using intuition on that one. And that makes sense, right? Because that's 20 and 21. Let's add 3. Okay, it checks. So that's the test code. So this should fail, right? We should fail on the first assertion. There it is. That's the first assertion. B00 should equal 3. All right. All right, we got the test code all ready to go. We did the boring part first, right? We did the boring part first. Now we're going to do the interesting part. We need to scan through every row and every column. And we know exactly how many rows, we know exactly how many columns. That triggers off a memorized policy that I have, and that is to use the for loop. So we're going to first we'll range through the rows. We could range through the columns first as well. I'm not sure which one is better. Maybe that gets too philosophical. And let's go through the rows. And then for every row I, let's consider every column within that row and add 3 to it. Now we can't use I. I is the column, is the row index. So we'll use J to be the column index. Remember to increment J and not I there. There's our nested loop. I ranges through from 0 to the number of rows minus 1. That's the last index. Oops, you see the mistake there? This should be a J. Just by habit, I put an I in there. There we go. There's a nested loop. Two different variables are being modified, I and J. Now, so the purpose of this is to consider every possible assignment to I and J so that we cover every element in the array. And so once we get there, we take what's in position ij and we add 3 to it. So we pull out what's in ij, add the 3, and then put it back in again. Now I think that at this point, I'm confident that the test code is going to run. There it is. I think that's good enough. That's enough test code, I think, for this. Let's go to the next problem. Random fill. Exercise 2. I know we're not going to need these. And we're not going to need these. But we're going to need vectors. So let's go ahead and put that in there. And that's my starting point, and I'm going to build that. And I'm going to run my trivial test code. And that's great. It passes. All right. Excuse me. Implement the function random fill declared above. That's enough for me right there. I'm not going to read any more. For the next stage of development, that is. We're going to need to go back, of course, and read everything. Implement this function random fill. That's it. So that should build. Notice the ampersand. So this function is we expect this function is going to modify the vector that gets passed into it. So that builds. Implement the function random fill declared above so that it fills the vector v passed into it with 100 distinct random numbers. Distinct means that a given number can appear at most once in v. Use the function ran to get random integers. Assume that v is empty when the function is called. Write test code that thoroughly tests the function. The test code should use assertions. Now the test code is just as complicated as the random fill code. You could make an argument that the test code doesn't mean much, because it's just as complex as the function itself. Let's think about what the test code would look like. Well, no, we can write simple test code that's not complicated. Let's think about it. So we have vector a vector of int a, And let's go ahead and it should be empty essentially. It's not a precondition, but it should be empty. We could make it a precondition. Maybe we should change the assignment. Assume the vector v passed into random fill is empty. I mean, that it just so kind of makes sense and it simplifies the problem. And so, in fact, we could put that assertion right here. V dot size should be 0. Let's put that in as an assertion. So we create the A, and we call random fill with the A, and it's going to fill an empty vector with 100 random distinct integers. So at the end of it, when we declare the A, and we put this assertion in there, that's our precondition, it needs to be empty. We call A, and then we can put, here's our first assertion. The assertion is that A dot size, after calling the function, should be 100, right? Because the function is supposed to add 100 random distinct, yeah, it should be 100 distinct random integers. Does that sound better? 100 distinct random integers. I don't just think that that's the right way to say it. So A starts at 0, we fill it, and then its size becomes 100. Let's see that fail. That should fail on us. There it is. Assertion failed. Okay. So we're kind of short on time here, so I'm just going to bang it out kind of quickly. And I'm going to use a while loop. I think that the conditions are too complicated to use something other than a while loop in a clean way. So we have while v dot size is less than 100. While it's less than 100, we have work to do. And when v dot size is 100, our work is done. And our work is going to be something like, it'll look something like this. It'll be like we generate a k, say, you know, whatever it is. This is a random integer, but it's not random now. We're just stubbing this out. Okay, random is not. So we set it to 99. So we get a random k. And so let's look at the steps. The steps are this, okay? Generate a random integer, and here's the example. So this is an example, k. Let's suppose k were to be random, and then verify that it is not already in V. Actually, it's easier. If the random integer is not already in V, then add it to V. There we go. So we got to have some test in there, and then we're missing that. You know, we're not doing that, but what it's going to look like is something like this. If k is admissible, then we're going to call pushback on V and pass in K. So we're going to be right now. We're just to test the test code. Really, this is where it's 199s. So the test should succeed because we're just verifying the size. Now I'm going to go a little faster because we're running out of time here. So that works. But let's actually, because it's 100, I think it's hard to write a test. But let's go ahead and do that. It's looks like this. The test is going to look like this. We're going to range through almost every element in V. You know, the test code is as complicated as the function itself. I'm debating whether to omit the test code. I think we can leave it in there. So we range through every element, and then we have another loop within there. We start at I plus 1. And while j is less than or equal to, this should be 99. No, I is 98. So let me think about it. So we pick the first number and we want to see if it appears afterwards. Okay. So we have to look at it like this. So we don't want to find two different numbers in the vector that equal each other. That's the thing. So we're going to compare v of I with v of j. So we want to compare every possible pair of values in the vector. That's what we're doing. So the test code is kind of complicated, and I need to go back and rethink this. You know, is this what we want to do? Well, you know, I is going to, we're going to compare, we're going to stop at 98 because j, the only possible value for j will be 99 at that point. And j, we don't exceed 99 because there's no index 100. And we start j at I plus 1, and because we don't need to check things twice. And then we just do this assertion. So this should fail. And then V was not declared in the scope. That should be an A. Yeah, the test code is kind of crazy. Sorry. There, yeah, that's what we want. The assertion failed. And now let's make it succeed. So we generate the random number up here. This is the random number. We can seed the random number generator. That's always a good idea. And it's srand. And we pass in time of 0. And what do we need for the random number generation? We need C time for the time, right? And do we need standard live? C standard live? Does anyone remember?
Yes.
We need that, okay. C standard lib. And so now rand will work. Let's see if it builds.
We need another parenthesis down there.
We need what?
By srand time is 2 open parentheses down there.
Thank you. Thank you very much. Let's see if that builds. Just to care about building. You know, I'm not going to try to run it. So we get rand, generate a random number, and then we have check to see if the random integer is not already in K. So we're going to use a for loop for that. For integer I equals 0, I is less than v dot size plus plus I, and we're going to do something like, we're going to have some kind of a condition here. I'm just going to sort of crafting it out one step at a time. If v of I equals K, and then whoops, I'm going to put that in there. In that case, we have K is already in V. Now, this is actually not that easy. How are we going to decide when to push back K? And I'm going to finish this out. I can't get into a discussion about that. You're going to need to think about it on your own. But here is one way to do it. We declare a bool, and we say that that K is good, and we're going to set that to true. And if we find that K is already in V, then we're going to say, hey, wait a minute, K is actually bad. Well, K is good, so we're not going to create K is bad. We're going to say K is good is false. And then we're not going to push this back until, we're only going to push it back if K is good. And when you do push back a good K, it increments the size of V, and that the while loop is conditioned on the size of V. And so this will terminate because we have so many random numbers. We're not limiting the random numbers. All tests pass, we got it. But who knows that the test code is right, right? Just quickly here, let's take a look at this. Well, I don't want to, I was going to print them all out, but that doesn't make any sense. Just see a bunch of digits. That's it. That's a solution for number 2, and next time we meet, we'll look at problem number 3. Anything? What's that?
It's due on Friday.
This is due on Friday? Okay. Number 3 is due on Friday? Let's work on it in the lab then. I think that 3 will be easier than 2. I think 2 is difficult.